Hi friends! This video is from a number of particularly interesting ones. The project of a laboratory power supply based on the popular scheme. It is now in front of you. And this is how it is looking. The archive of this project can be downloaded from the first link in the description. The laboratory power supply is single-channel, fully linear, with digital indication, current protection, and there is also a limitation of the output current. So, the power supply can provide an output voltage from 0 to 20 volts and current from 0 to 7.28 amperes. It is possible higher parameters, up to 20 amperes and up to 30 volts. But my version has a limitation because of the transformer I used. The essential things are how stable it is and output pulsations level. Well, let's see what this device can do. Load is the lamp from the film projector, very powerful. The voltage is set at 13.5 volts. I connect the lamp is 7 amperes, but the voltage hasn't dropped. That's how stable it is. Surprised? Then I will continue. With a current of 6 to 7 amperes, pulsations are of only about 5 millivolts. Unfortunately, it is impossible to set the oscilloscope sensitivity better than 20 millivolts per division. The budget Chinese power supply units of industrial design have the same pulsations, but with currents as low as 1 to 1.5 amperes. That is, this unit is much more stable and can compete with the devices for a couple of $100s. Despite the fact that the unit is linear, it has a high efficiency. It has a system for automatic switching of the relay, which will reduce the power loss on transistors at low output voltages and high current. This system is built on the basis of 2 relays and a simple control circuit. But later, I removed the board since the relay, despite the claimed current of more than 10 amperes, failed to work properly. I had to buy powerful relays of 30 amperes. PCB for them isn't ready yet. I will add it later. But unit works fine also without the switching system. By the way, with the switching system the unit will not need active cooling. A huge radiator behind is enough. The box is from the Industrial Network Stabilizer. A new stabilizer was bought from the store only for the sake of the box. Was left only a voltmeter, a network toggle switch, a fuse, and something like a plug. An extra socket will never interfere. Under the voltmeter are 2 LEDs. One shows that the stabilizer board receives power. The other, red, indicates that the unit is operating in the mode of current stabilization. Indication is digital. By the way, it is a personified indicator as evidenced by the greeting. In fact, it is a volt, ampere, wattmeter. Below the display, there are 3 buttons that will allow you to set the protection current and save the value. The maximum current is 10 amperes. Relay protection is realized, but, as I already said, this type relay is weak, and at high currents, the contacts are heated quite strongly. At the bottom are the power terminals and the output fuse. By the way, there is protection from a fool. If someone once will use this unit as a charger and mix up the polarity of the connection, the diode will open and burn off the fuse. Now about the scheme. It is well known and in demand. It is collected by many. Plus, the Chinese mass-produced it. In this power supply use the Chinese model, but with great changes. Here is the scheme. Red color is highlighted what was changed. The bridge is full wave, made on 4 powerful double Schottky 4030 diodes, 40 volts, 30 amperes. Diodes are in TO247 case, in one case 2 diodes. I connected them in parallel. Eventually, I got a bridge with very low voltage drop and losses. At maximum currents, this bridge is hardly warm. But despite these, the diodes are mounted on an aluminum heatsink in the form of a massive plate. The diodes are insulated from the radiator by a mica gasket. A separate board was created for this mode. Let's look at the power part. The origin scheme was of only 3 amperes. Reworked easy can give 8 amperes. The keys are already doubled. These are powerful 2SD2083 composite transistors with a collector current of 25 amperes. The keys are essentially paralleled. In the emitter circuit, there are equalizing resistors of 0.05 ohm meter 10 watts, or to say more precisely, for each transistor are used 2 resistors of 5 watts 0.1 ohm meter in parallel. Both keys are mounted on a massive heatsink. They are isolated from the radiator. This can be avoided since the collectors are common. but the radiator is screwed to the housing, and any short circuit can have deplorable consequences. Then was replaced the current shunt. Low resistance resistor was 0.47 ohmmeter. It replaced by 4 resistors in parallel. Each resistance is about 0.33 ohmmeter. Power is 5 watts. Smoothing capacitors after the rectifier have a total capacitance of about 30,000 microfarad are connected in parallel. The current shunt and capacitors are located on one print circuit board. The transformer provides an alternating voltage of about 22 volts and a current of at least 8 amperes. There are taps for 9 volts and 15 volts for the switching circuit. All the power wires are 2.5 square millimeters cross-section, quite reliable. Display and the board with the buttons attached to the front panel in a tricky way. Instead of drilling screw holes, I decided to solder the same screws inside of the case. Finally, everything turned out fine, except that, due to the overheating, damaged leather film in some places. To completely remove any noise from the transformer, it is screwed through rubber gaskets. This ensures a reduction of vibration and noise at the same time. I hope this video was useful for many. The project, I think, is successful, but not completed yet. And when I finish, I will make for you another video. I'm planning to add something else, but about this another time. In the description, you will find all the necessary information, as well as links to my power supply unit, which I have been using very actively for a year and I am very pleased. Please don't forget to put thumb up if the video is helpful, and of course, share it with your friends. Now I say goodbye. With you was Kasyan TV.